Welcome, everyone. I'm glad you're here, and I will turn it over to Steve Holmes.
Thank you, Cindy. Yes, I want to welcome everybody here this morning to our IP for the Operator and Engineer 101. This is just going to be very simple, not so much what is IP, but how do I just connect? How do I get from SDI to here to do just some of the same basic things that I've done before? And we definitely welcome your questions. Please type them in the chat window, and Cindy and I will review those at the end of the session. So let's get going. So today's webinar, we're going to look at the Leader LV5600 and the PHABRIX QX unit, and how to connect to an IP stream, how to set up to view video, audio, how to look at SDI and IP in both products, but then in the 56 or 7600 has the ability to actually view both of them at the same time, side by side, up to 4 independent inputs. So we'll take a look at that. We are going to have some upcoming webinars that we are going to go a little bit deeper with both the Leader and the PHABRIX products and start looking at physical layers, look at packet errors, IP packet jitter, SFP data, and then we'll have more coming up getting deeper into looking at timing, buffers, and then whatever comes up that either I can dream up or your questions generate the need for. The one thing we have to remember is IP is just another I/O interface. It is just another way to get video and audio from one point to another, or get it from a switch to a receiving device. In SDI, would hook up a BNC cable to a router. You hook up the BNC cable to your waveform monitor, and nothing would happen until you tell that router what to put on that video cable. So not much has changed in that. We still have to, in the IP world, still hook up a fiber to a switch. You hook this fiber to your waveform monitor, and nothing happens until you tell things what you want to do. There's just a couple more steps involved in IP. Yes, you have to tell the switch which multicast you want to be able to view. You need to, in 2110, as we'll look at, you need to be able to put the program together. And then you need to also tell the waveform monitor what IP you want to configure the waveform monitor for. It's just how we do things in that little bit of extra stuff that have changed, but the basics is still the same. In SDI, you'd have an input coming into a router, you'd have an output going to the router, and the router essentially just connects that input coax to that output coax going to your waveform monitor. Well, in IP, that input fiber probably has a lot of programs on it, a lot of data. So we have to be a little more selective because you want the one program. So within the world of IP, we need to select the multicast out of the hundreds or thousands that are sitting on that switch that we want to be able to view. 2110 separates the video, audio, and ANTS data into essence flows. So when we set up and we need to be able to look at a program in the 2110 world, we need to know who is the video, who is the audio, and who is the data if you're going to look at the data channel. those three flows make up your program. So there's a little bit more that you need to know if you're going to set this up manually than what you would have to with a SDI convention. You know, in SDI, when we make a route, like I said, we're basically hooking the input coax to the output coax. In the IP world, there's several different flows that are on that. So when you go to a router panel and you're in the IP world and you hit source, destination, and take for a program, there's a database someplace that has put those essence flows together and will deliver those essence flows to you as a program. But what do you do when I push source, destination, and take and nothing happens, or one piece of the program, the audio or the video or the captions, are missing? So the remote panel needs to talk to the switch somehow, and it's either going to be using a custom I/O, or in today's world, we're leaning more and more to using NMOS to control the system. And we need to be able to put those IP flows together. So there's a little bit more about the configuration you need to know. You know, is it coming in as starting as IP? Did it start as SDI? Is it ending as SDI? In a lot of cases in today's world, there's still a fair amount of SDI involved in all of this. The thing to remember, though, is in this world, troubleshooting itself has not changed. It's still a divide and conquer. The I/O has changed, but how you go about tackling this is still pretty much the same. You're still going to end up going into the middle and see if, hey, is it coming in? Is it not coming in? That way you eliminate half of the network and half of where you need to look. But you need to know where these pieces are and how to get to them. So you can connect typically one of two ways to an IP flow. So you can use a IGMP join command, or you can use NMOS. IGMP is set up to manage switches because they've got thousands and thousands of flows on them. And if 3 people want the same video, you don't want to have to turn around and duplicate that flow 3 times. The same flow can sit in the switch, and each of the 3 users can actually join that same flow and use that same data. But you have to be able to tell the switch, that's the one that I want. So there's a few more pieces with that join command. NMOS, which is the Network Media Open Specification from AMWA, sets up a database where transmitters and receivers register themselves. Transmitters will register themselves, say what flows they have, what's on those flows. Receivers will say what they can receive, and then you can use that to manage the network. And typically your router panel that is, in a lot of cases, still doing some SDI and some IP can still manage that pretty much the same way we've done in the past. There are a few things you still need to know about the multicast. So the biggest thing is you need to know what is the destination address. It may seem a little different. You don't need to know the source in virtually all cases today. Maybe in the future, we'll have to have the source data when we get into SSM and a few other things. But right now, you need to know what the destination address. Also, 2110 uses RTP flow types. So For video, audio, and metadata, there are different RTP types. So typically, video is set up as type 96, audio is set up as type 97, and data is type 100. But it is an open standard from that point. Anything from 96 to 127 can actually be assigned to those individual entities. It's just that most of the folks dealing with this stuff now have pretty well stuck to 96, 97, and 100, but it does not have to be. So that's where things might get a little bit dicey. You also need to know the port number that has been assigned to the flow. Just like if you put in an IP address into a browser, it automatically connects on port 80. And a lot of us have seen where someone has set up something for remote connect and it may be on port 8080. 8080 is quite often a secondary IP web server address. So you need to know some of the data if you're going to manually deal with this in troubleshooting. You can use your LV5600 to look at the SDI feeds as well as the IP feeds. And one of the beauties about the 5600 is it's able to look at multiple feeds at the same time. You can switch between them, or you can actually have up to 4 independent streams, any combination of IP or SDI, on at the same time, which really, really helps in dealing with troubleshooting and looking at things. It also has the ability to do, which we will cover in another session, things like AV delay. You could actually start off coming out of an SDI server and look at the final product in IP and still verify that we haven't gotten into any situation where we get into lip flap. We can also use the PHABRIX QX to look at the SDI feeds or the IP feeds. So it has the ability to look at both of these feeds, and we can bring either SDI or IP into the PHABRIX QX. And we'll be taking a look at that from the IP side of the house in just a little bit. PHABRIX also has a gorgeous little handheld, which is the SX tag. The SX tag has the ability also to look at IP flows as well as SDI flows. So it does have a SFP converter module, which is a de-encapsulator and an encapsulator. It can generate IP flows and it can decode IP flows. And it's gorgeous in its form factor for being able to take it behind the racks and look at things very quickly and be able to get from place to place. And if you have to move from one place to another to start troubleshooting or looking at things, it can get you there very quickly, and is a gorgeous thing to have and take with you to be able to look at things remotely. Likewise, you can use the Leader or PHABRIX products to look at an all IP network. You could look at the source, that the playout server that is playing out the material. You could look at the switches all the way through, all the way up to what is being delivered to the world. So both products can walk through and look at both pieces. So if you're going to use this, you're either going to have to manually set it up with a IGMP join command, or you're going to have to use NMOS or another third-party I/O. But NMOS is pretty much the one to be able to set the waveform monitor up to look at the flow that you want to look at, where you want to look at it. One of the unique things is that if you are looking at a source, and you plug into the source just to make sure the source is outputting the data that you think it should be outputting, you will see automatically, as soon as you plug in, every flow that that source is producing. The IGMP managed piece does not happen until you enter the switch. So once a flow comes into the switch, it gets managed by the switch, and that's where IGMP is going to take over and have a managed piece to that. But you will see all the flows that are sitting in there, and you'll need to be able to pick out and still set up the waveform monitor, though, to see which ones you're going to see. You most likely will not see PTP, but there's a possibility that PTP will be coming out of the source, but most likely not. There is the case that looking at a COTS IP switch, which is a commercial off-the-shelf, like an Arista or Cisco and the like, that you plug into that switch, the only thing that you're going to see is PTP, because PTP is automatically joined by the receiving device. You will have to configure the waveform monitor, do an IGMP join command, or set it up via the NMOS SDP file to be able to look at and see the data that you want to turn around and see. Once you put that data in, then you will see your video flow and your audio flow. So your video flows will be the -20. The audio flows will be the 2110-30 flows. And if you look at the bit rates on there, you can see that in this case, the video flow is about 1.3 gigabits per second. The audio flow is about 965 megabits, or excuse me, 9.65 megabits, not 900. And on the far right, at least in this particular view, it also is telling you the packet type, whether it's a 96, 97, and in this case, it is showing the domain for what the PTP is, but that's a whole nother subject. There is the possibility that in a non-COTS type switch, say like an Evertz EXE switch, you'll have to also still manually manage the switch. It does not use IGMP. It still deals with the system via NMOS on their own control on the back side, but you'll also, in this case, have to tell the switch which video you want to see. Then you'll also have to still set up the waveform monitor as to which IP address, port, and RTP type that you want to end up looking at. So there are instances where you may have to turn around and look at a flow and see what's going on. So if we take a quick look here, just 1 second. Let me set something up quickly here. Log into my little guy. So give me just a second.
If you have questions for Steve, now would be a great time for you to pop them into chat, and we will definitely address those at the end.
Yes, please. I'm just setting my waveform monitor up here. So if we turn around and look, so right now I am looking at the LV5600 and I am looking at my input, and you can see I can see several different flows that are on that. Oh, come on. Excuse me for a second. There we go. And when you plug into a switch that is outputting data, you can see there are many different videos that are coming out of this particular server that I have running right now. There's multiple audios, and I can, turn around and scroll down, and you can see that there's a lot of stuff coming out of this particular source. And I would have to turn around and select which one of these. So you need to know the destination, the 239 address of the particular data you want to see, to put it together to see what you want. And we'll take a peek at that. Also, you'll notice that there is all of this data also going into the QX, and you can see many, many, many different flows coming into the QX here, and you can see the same data. But to be able to view any of them, you're going to have to turn around and click on them and tell them what they are and who you want to actually look at to see which data that you want to see. So I could click on here, tell this one that is a -20, and then I could actually walk over to a completely different video flow, or walk back to the other video flow that are there coming into my particular source. I'll cover setting both of these instruments up in more detail in just a second here. So the first thing we're going to take a look at here is, let me switch something here. Get set up for the next piece. Is how do you set the boxes up? How do I look at the different pieces? So as I've said before, the LV5600 can look at 4 inputs at once. So you need to be able to assign how you want to look at things and what it is that you want to turn around and look at. You also need to be able to tell it what IP address, the 239, in this case 20.101, and what destination port it is that I want to turn around and look at, to be able to view that data on the waveform monitor. And then you can use the conventional controls and look at waveform, vector, picture, audio, and all the other pieces when we turn around and look at that. So if I switch back over here and look back at my 5600, I've moved myself onto the managed switch, and you'll see the only thing coming in to the waveform monitor from the flow table happens to be the PTP that is running, which is your sync source. So I would need to go in and configure the 5600 or 7600, how you want to turn around and look at this data. So the first thing in this case is, since I have the ability to look at 4 inputs, I can make any one of these inputs either IP or SDI. In the case of how I'm going to set it up right now, I'm going to make the first 2 SDI1, SDI2, but then I'm going to set it up for IP stream 1 and IP stream 2, so that I've got 2 different SDI sources coming in. Both of these SDI sources are being converted to IP, and then the IP streams of each one of these I can turn around and look at. So if I go to IP setup 1, I can go to my first IP flow on my first IP input and say I'm going to look at the destination address, and I can fill out 239.20-1-1 and port 20,000, which is what my little cheat sheet tells me that this particular video is. This is where you have to have the Excel sheet or know the source and what it is you're looking at. So in this case, I'm going to set up 239.30 for my audio. It is from vendor 1. It is my first flow from that vendor that I've set up, and it's also on port 20,000. And if I hit the complete button, those flows should join, and they did. So you see the -20 flow, you see the -30 flow. So on my input C, I should now have my IP that should be the same as my SDI-A. So if you look at the top of the screen here, you'll see on the left-hand side, it's looking at SDI-A, which was the SDI input. On the right-hand side, I'm also looking at the IP of that same particular video. I can also look at it with waveform and vector, the status screen, and see the video and look at it. I could go back in and set up my flow 2 and set up its destination address. In this case, it's 239.20, and I use the 3rd octet to separate my vendors. So I always use the 2nd octet to tell me if it's audio or video, just to make it easy for my home lab here. And this is my 2nd vendor, so he's number 100, but it's the first audio or video flow out of that vendor. And then I can come down and turn his audio on. It's a -30 flow. It's my 2nd vendor and his first audio flow, and hit complete. That would be how you would turn around and on a 5600 set up your video and audio. On the PHABRIX, quite often you're going to walk into a stream and you actually may see a lot of data on the screen because it can do many different functions of which we don't have time to cover all of them right now. But you can, right on the menu bar, right click on it. You can say close all of the windows and you'll go back to the PHABRIX logo. You can turn around and click on the PHABRIX banner down on the bottom and go up to switch mode to, and we'll look at that in just a second here. So the PHABRIX QX. So since the QX can look at either IP or SDI, as you saw there, it can have a lot of different data on the screen. So one of the easiest things you can do with it is just close all windows, get a clean, fresh start, right click on the menu bar, say close all the windows, and then put it in 2110 mode if it's not already in that particular mode. Then you can go in and set up configure the multicast flows and go ahead and join the multicast flow that you want to join. Tell it, is it a -20 flow, a -30 flow, a -40 flow, an auxiliary, and then you can turn around and select the individual analyzers that you want to use. So if I go up here and go to switch mode to 2110 is not listed, so that means that is the mode that I currently am in. So I'm good to go there. And then we can go down and tell it, I want to turn around and receive a flow. You get the multicast request window up, you right click on it, you go to multicast flow configs, and this is where you can turn around and enter your multicast number. So in this case, put in one of those two flows I was just looking at, 20-1 1, and say join. And you notice in my multicast window back here in the back, it has joined that, but it doesn't know what type it is, what the protocol is. I know this is my video flow because of my cheat sheet. So I can just click on this and tell it it is a -20, it's my video flow, add it to the configuration, and now it sees that it is my video. Now I can go turn on one of my analyzers, and one of the first things you typically want to do is the picture there? And we have picture. And then I can turn on other analyzers and go down and select the audio. I can select status. I can select CIE, picture copy, and waveform. And then you can position any of these any place on the screen you want to turn around and position them. You can take a waveform, double click on it, make it full screen, make it small, make it larger. Same thing with the picture, so you can double click any one of these. You can move them around where you want to place them and have them placed wherever you want, and turn around and configure it as you need to. But in the case of configuring your multicast, you right click on the multicast request window, and then you can turn around and either manually input the data, or if you have your keyboard connected, you can turn around and type in the data and do your join, and the information will turn around and come up on the screen itself. So that's a quick 1, 2, 3 of configuring both the Leader LV5600 to turn around and view flows, or configure the PHABRIX QX to turn around and view flows and look at the data that is coming in. So Leader has both products available for you and can turn around and look at either one of the two very nicely, very easily. Then, you, as I said, with the QX, you just pick up the analyzer you want to turn around and place it on the screen, position it, and move it around. The things to remember with all of this is IP, as I've said, is just another I/O interface. You need to know what multicast to expect, what multicast to set up. You need to know the destination address of that multicast address, and that 2110 uses independent flows for the video, for the audio, and for ancillary data, which will be your captions. Also, you know, troubleshooting itself fundamentally has not changed. It's just the connection to that data that has changed and how you're going to turn around and connect to that data independently. I know this was a little bit of a whirlwind tour, but within the time allotted for these sessions, the best thing you can do is get your hands on the products and go connect to flows. The nice thing about it, when you're receiving a flow, you're just receiving the data. You're not going to change anything that's in the switch or bother anything else. So the only way to do things here is just get your hands on it and practice with it. And if you have issues, give us a call and we'll help you out. And now we'll take a look at some of your individual questions. Cindy?
Ooh, we do have some questions here. Thanks, everybody. All right, Steve. So one of the questions is about the, it's an NMOS question, and wondering if the Leader PHABRIX devices have a built-in way to discover or see all the available sources on the network, separate from IGMP or NMOS control of an external device.
No, they do not. They are set up to be ISO4 and ISO5, which they'll register themselves onto the server, but they do not view what is in the registration server.
Gotcha. And another question is on the LV5600, can the vector scope monitor deal with different color spaces?
Yes, we can deal with 601, 709, P3, XYZ, and then also deal with any of the other color spaces when you get into HDR.
Okay. And then a question about the LV5600 versus the PHABRIX QX. Which applications work best for which piece of equipment?
Well, that's where it gets into user preference. The tendency is a little bit that the 5600 is a little bit more geared towards the post community and a little bit on QC, and the QX might be geared just a little bit more towards the engineering side and the lab side, but both products work absolutely perfect doing all of it.
So here's a great question about just moving between SDI and IP. Just wondering what equipment is required to convert SDI signals to 2110. And this is asking about the LV5600.
So in my case, I've got a couple different, I've got an AJA converter, I've got an embryonics converter. There are many different glue products out there that will convert from virtually everybody who makes SDI equipment, that will convert SDI to IP. So all of that's being external to the 5600, and I'm just using one of the inputs to connect to SDI or connect to the IP flows. But there are many, many, many different devices on the market that will, what they kind of term as, encapsulate the video and audio into an IP flow.
We have a question asking about the example slide that you had where it was titled "What Flows You Can See." And so in looking at that example, this question is around media and essence. So the question is, the flow has a multicast destination of 239.20.100.x, while the audio flow is 239.30.100.x. And what they're asking is typical or built into the standard? And
it is the 239 sets you up as multicast. The next 3 octets are how you configure your system. I just configured my lab very simply for me to where I made the second octet be 20, 30, or 40 just because it tells me if I'm dealing with audio, video, enhanced data. And then the third octet is which vendor's equipment that I'm grabbing that flow from. And the last octet for me is which one of the flows they are. So mine just starts out at 1 and goes up through first video, second video, third video, same thing with audios. But it's up to the engineering department. Doing it that way is fairly restrictive and doesn't allow for a lot of possible flow types or the amount that you may deal with. So that's just my own little thing. The last 3 octets are however you want to set them up.
So the 20 and the 30 are, well, that was your choice.
That was my choice to make my life simple in my lab. I want to thank you very much for attending. Please let us know if you have any other things that you would like us to cover in future seminars, and we will have future seminars that will progressively get deeper and deeper and deeper, looking into some of the other tools available that are helpful for doing troubleshooting and for being able to look at IP flows. So with that, I wish you all stay safe and have a great day.